Section 5.4 deals with some of the other identities on the yellow sheet. First, we need to start with something that looks like this. When you have sine of 45 plus 20, that is, you can take these two things here, 45 and 20, and add them together to get 65 degrees. So that would be sine of 65 degrees. Now you have to understand that that is not the same as sine of 45 plus the sine of 20 degrees. Those are two separate things. This does not get distributed to those. Instead, you just add them together and then take the sine of that. Or you will use one of these sum or difference identities to come up with a value or an answer to a problem. And there are two for sine. One is two angles added together, one is two angles subtracted. There's two for cosine, same thing, and two for tangent. And all of those identities are found on your yellow sheet right in the middle of it, where it says sum and difference identities. And you can look at them there. I'll read you the first one. It says sine of x plus y equals sine of x, cosine of y, plus cosine of x, sine of y. And so, how do you use these identities? Well, here is how. You have to find an exact value of, say, the cosine of 75 degrees. We do not know the exact value of cosine of 75 degrees because we only know a few of those, like 45, 30, and 60, and 90, and so on and so forth. Those from our unit circle that you've taken quizzes on and just love to take every single week. So, what way can you write 75 degrees other than as 75 degrees? Well, there's many different ways. One of them would be like 60 plus 10. Another one would be 50 plus 20. Another would be 40 plus 35. And those other two just don't add up to 75 now, do they? That was for you people who weren't following along. That would be 15 and that would be 25. Now we have 75 for all of them. But as I said, none of these work. But if we flip that over, we could possibly go to 45 and 30. And don't those two add up to 75 as well? Yes, they do. And do we know the degree measure of a 45-degree angle? Yes, we do. Do we know the degree measure of a 30-degree angle? Yes, we do. So now we can write 75 as the cosine of 45 degrees plus 30 degrees. And so then from our handy dandy trigonometric identity sheet, we know that the cosine of an angle plus another angle, we'll call this one x and that one y, it is cosine x cosine y minus sine x sine y. And so using what we have here of 45 and 30, we would have cosine 45 degrees cosine 30 degrees minus sine 45 degrees sine 30 degrees. And then from our memory, we would know that the cosine of 45 degrees is the square root of 2 over 2 times the cosine of 30 is square root of 3 over 2. And then we would subtract sine of 45, which is the square root of 2 over 2, times sine of 30, which is 1/2. Now it's just a matter of doing some math. Simple stuff, like the square root of 2 times the square root of 3 is the square root of 6, and 2 times 2 is 4. And then minus square root of 2 times 1 is square root of 2, and 2 times 2 is 4 also. And then we can add this together because they have common denominator, and so we would get a final answer of square root of 6 minus square root of 2 all over 4. And that is the exact value of cosine of 75 degrees. And like I stated earlier, that is not the same as saying what is the cosine of 45 degrees plus the cosine of 30 degrees. That is something completely different because the cosine of 45 is the square root of 2 over 2 and the cosine of 30 is 1/2. Or no, square root of 3 over 2. And that would be the square root of 2 plus the square root of 3 over 2 as an answer. Completely different. You will be doing this more often than not. Another example, tangent of 75. Same thing, 75 is same as 45 plus 30, so we would have tangent of 45 degrees plus 30 degrees. And that would be from your yellow sheet. Tangent of x plus y is tangent of x plus tangent of y all over 1 minus tan x tan y. And so then substituting the values in, you would have tangent 45 plus tangent 30 all over 1 minus tangent 45 tangent 30. And so then figuring all these out, tangent of 45 is 1. Tangent of 30 degrees is the square root of 3 over 3. And 1 minus 1 times the square root of 3 over 3. And so then you have to do some simplifying. For the numerator here, you need common denominator, which would be 3. And it would be 3 plus the square root of 3 over 3. And do the same thing in your denominator, multiplying these two together, you just get the square root of 3 over 3. And here you'd get 3/3 minus the square root of 3 over 3 equals 3 minus the square root of 3 over 3. And then because you have a fraction inside of a fraction, you would then multiply by the reciprocal, which would then have 3 plus the square root of 3 over 3 times 3 over 3 minus the square root of 3. The 3's would go away, which gets you 3 plus the square root of 3 over 3 minus the square root of 3. And since you can't leave a square root in the denominator, you'd have to multiply by the conjugate. And then you would get 9. And then that would go away, minus 3. Oh, the conjugate would be plus. Another mistake. Keeping you on your toes today. So then, let's see, that's 9 plus 2 square root of 3. No. Let's see, that's 3 square root of 3, and that's 3 squared, so that's 6 square root of 3 plus 3, which is going to be 12 plus 6 square root of 3, and the denominator is going to be 3. Let's try 9 minus 3, which is 6. And then when you divide that, 12 divided by 6 is 2, and plus the square root of 3. And so that is what tangent of 75 degrees would equal. Now then, this next example, it's tangent of pi over 12. Well, pi over 12 would be the same as pi over 3 minus pi over 4. And it would be the same thing. And then you would have to go through all of that. Let's see. So you would have tangent pi over 3 minus tangent pi over 4. And then it would be 1 minus tangent pi over 3 tangent pi over 4. And tangent of pi over 3 would be the square root of 3. Tangent of pi over 4 would be 1. And then you'd have 1 minus square root of 3 times 1. So then you would have square root of 3 minus 1 over 1 minus the square root of 3. Did I write that wrong? Yes, I did. This is supposed to be a plus. That's what I get for rushing. So now you would multiply this by 1 minus the square root of 3 on the top and bottom. And on the bottom you would get 1 minus 3. And on the top you would get the square root of, that's the square root of 3. That's the square root of 3. So that's 2 square root of 3. And then 1 times 1 is a negative 1 and a negative 3. So then that would become a negative 4 plus 2 times the square root of 3. And then you would get a negative 4 plus 2 square root of 3 all over negative 2. And then you can divide by a negative 2 to get 2 plus, to get 2 minus the square root of 3. And then finally, with something like this, cosine of 30, sine of 20 minus cosine 20, sine of 30. If you look at this, this is going to be, it's a minus and it's cosine sine, so it's either got to be sine of x plus y or sine of x minus y. And since it's minus in there, it's sine of x minus y. But now it's written backwards, so this is actually your x value and that is actually your y value. So then you would say sine of 20 minus 30, which is negative 10 degrees. And so you have sine negative 10. And then from your even odd identity, sine of a negative angle is the same as negative sine of 10. With our second example here, it's pi over 5 minus pi over 3. So then that is, because it's cosine, cosine, sine, sine, it's going to be cosine of two angles, and it's going to be pi over 5 and pi over 3, and it's going to be plus in between. And adding those two together, common denominator is 15, so this would be 3 pi, and that would be 5 pi. And when you add those, then you would get cosine of 8 pi over 15. And there you can do nothing else with it. And so those are what the things you're going to do in section 5.4.